Hello students, welcome back to mathematics class. In today's class, let us prove a very important theorem, nothing but that is Pythagoras theorem. Before learning Pythagoras theorem, one more theorem we have to learn. So let us learn that first. Okay children, see here, if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangle on both sides of a perpendicular are similar to the whole triangle and to each other. Okay, so what is the meaning of this? See here, if a perpendicular is drawn from the vertex of the right angle of a right triangle, means which triangle I have to draw now? I have to draw one right triangle, means right angle triangle I have to draw. Let us draw now. So, right angle triangle A, B, C. Okay, let us take B angle is 90 degree. Okay children, so see here, if a perpendicular is drawn from the vertex of a right angle, where right angle forms here, no, from this vertex angle, you have to draw one perpendicular to whom? To the hypotenuse. Who is hypotenuse in right angle triangle children? In right angle triangle, 90 degree front which the side is there, that is called as hypotenuse. Okay children, this is called as hypotenuse, which is called as longest side in a right angle triangle. So what we have to draw children for this longest side? We have to draw one perpendicular. Okay, so let us draw one perpendicular. Okay, so this side is called as a hypotenuse. This is called as base, means this is called as perpendicular. So three sides of a right angle triangle are hypotenuse, base and perpendicular. So three sides are there, right children? So here, now you have to draw one perpendicular from the right angle where it forms to the opposite side of that, which is called as hypotenuse. Let us draw one perpendicular for that. Okay, so what they said, like that only we have to do. See here, if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle and also to each other. So what is the meaning of this? You know, when I draw one perpendicular to the hypotenuse, this is a perpendicular. Perpendicular means how much degree? 90 degree children. Correct no children? So here this angle is 90 degree. This angle is 90 degrees. So what we can take here? B or ADB. ADB is similar to triangle ABC. Also BDC similar to triangle ABC. So when their two triangles are similar to the whole triangle, then to each other they are similar. In the sense ADB is similar to BDC, means that sentence says. Is it okay? Understood children? So what you have to prove? ADB similar to ABC. BDC similar to ABC. That time these two triangles also similar, means you have to prove. Okay, very small theorem. This is the very important theorem to prove Pythagoras theorem. Is it okay? It's the base for that. So let us learn now. See what you have to do first. What is given children? ABC is a right angle triangle. So given, what is given? Triangle ABC. Okay, in triangle ABC, in triangle ABC, angle B is how much degree? 90 degree. Okay children, when you draw 90 degree, when you draw perpendicular to this, how many triangles forms? They are all similar to the whole triangle, means I have to prove. So this much you know. Now what you have to do children? What you have to prove? So what you have to prove? And triangle ADB, triangle ADB is similar to triangle ABC. Okay, so then triangle BDC is similar to triangle ABC. When things which are equal to the same things are equal to one another. Therefore, triangle ADB is similar to triangle BDC. Means you have to, these three things you have to prove. Is it okay? These three things you have to prove. To prove that what you drawn already perpendicular. So it is given there already. Yes, no children? Perpendicular drawn means what will happen? So you can write here BD is perpendicular to AC. BD is perpendicular to AC. Okay. So now what you have to do? You have to prove this. How to prove? Let us see how to prove. Now in triangle, which two similar means I have to prove? That we will take here. Is it okay, children? In triangle ADB and triangle ABC. In ADB and ABC, how can I prove they are similar, children? How can I prove they are similar? See here, ADB and triangle ABC. ADB, how much degree? D is 90 degree. Then what is angle B? That is also 90 degree. That means angle D and angle B are both are right angles. So angle D is equal to angle B is equal to how much degree? 90 degree, children. Correct? No. So while writing you can write angle D is equal to angle B is equal to how much degree? How much degree? 90 degree. Correct, children? Then while reading, one angle is common there. Who is there? Angle ADB. Angle ABC. Who is similar? Who is same? Angle A is same. Right, children? Angle A is same. So what you can write? Angle A is equal to angle A. That is called as common. Because of this, these two triangles are similar. These two triangles are similar. Similarly, we can prove this also, children. BDC. You have to compare BDC and ABC. BDC and ABC. Can we see there? So, you can write there. Similarly, we can prove and triangle BDC and triangle ABC. Similarly. Okay, so now from this 1 and 2, what you can say? This is 1 and this is 2. What you can say, children? Things which are equal to the same things are equal to one another. Therefore, triangle ADB. Triangle ADB is similar to triangle BDC. To each other. Both the triangles are similar to each other. So, ADB similar to ABC. BDC similar to ABC. So then these two triangles are also similar, means we can say this is through axiom, right, my children? So this is just a proof of this theorem. Using this theorem, we have to prove now very important theorem, that is nothing but Pythagoras theorem. Let us prove it now. Okay, children. Now what is the theorem says? Let us see. Okay, so very important theorem, that is nothing but Pythagoras theorem. Pythagoras theorem. What he says here? In a right triangle. In a right triangle, the square of the hypotenuse, square of the hypotenuse is equal is equal to the sum of the squares of the other two sides. Sum of the squares of the other two sides. Okay, so now what is given? See, he says that in a right triangle. So what you have to draw first? On a right angle triangle I have to draw. Let us draw it now. A, B, C. Okay, right triangle at B. So in triangle ABC, right angle at B. What happens here? In a right triangle, the square of the hypotenuse. So just now I said, which is the hypotenuse here? 90 degree front, which side is there? That is called as hypotenuse. So hypotenuse is AC. Correct, children? So hypotenuse is AC. Then see what is this? The square of the hypotenuse meaning what? AC is the hypotenuse. Square of the hypotenuse means AC square is equal to the sum of the squares of other two sides. Which are the other two sides here? This and this, right? So sum of the squares of the other two sides means AC square is equal to AB square plus BC square. Can I write here? So AB square plus BC square. Is it okay, children? So hypotenuse is AC. AC square is equal to AB square plus BC square. Square of the hypotenuse is equal to sum of the squares of other two sides, said by Pythagoras. This you have to prove, children. Okay, so 90 degree front side is called as hypotenuse. AC square is equal to AB square plus BC square means I have to prove. Let us prove now. Yes, children. So what is given? Right there. Given. What is given? In triangle ABC. Okay, children. In triangle ABC, angle B is how much degree? Angle B is 90 degree. Angle B is 90 degree. Then what to prove? To prove AC square is equal to AB square plus BC square means you have to prove. Is it okay, children? AC square is equal to AB square plus BC square means you have to prove. Then construction. So what you have to do? One extra fitting you have to do. So construction what you have to do, see here. To prove this, we have to draw one perpendicular. Okay, children. So BD. So this is 90 degree, this is 90 perpendicular. So let us write here. Draw. Okay, so draw BD perpendicular to AC. BD perpendicular to AC. Okay, when I draw the perpendicular, in the previous theorem you already seen. When you draw any perpendicular, how many triangles forms? Two triangles. Both are right angle triangle, children. Right, no, children? Both are right angle triangle. So you already know that where there is a perpendicular drawn to the hypotenuse, then the triangle forms are similar to the whole triangle. Just now we have seen a triangle ADB. Yes, similar to triangle ABC. You already learned now. Yes, children. So even BDC is similar to triangle ABC. This you learned or not? Through the theorem, we have to prove this. So through the previous theorem. So let us prove now. Yes, children. So what you have to do, see here, prove. So now already I know from the theorem that triangle ADB is similar to triangle ABC. So I will take here in triangle ADB is similar to triangle ABC. I already proved the theorem. From the theorem. What's the theorem says that you want to write its statement. If you are writing, you can write. What's the statement in? We learned in the previous this one. See, if a perpendicular is drawn, if a perpendicular is drawn from the vertex of the right angle of a right triangle is to the hypotenuse, then triangle on both sides of a perpendicular are similar to the whole triangle. So this you already learned from the theorem. So we can say that ADB is similar to triangle ABC. Right, my children? If two triangles are similar, then their corresponding sides are in the same ratio. Why I have tried corresponding sides? Because I want their sides square, children. So AB square I want, BC square I want, AC square. So how we can get? By writing the ratios, children. So when two triangles are similar, then their corresponding sides are in the same ratio. So now ADB is inside ABC. So which are the corresponding sides, children? It's very difficult to understand. Means what you can do, see here, you can draw the triangles separately. Both are right angle triangle. In the sense, what you can draw, see here, you can draw ADB. How it is there? ADB. Right angled at B. So that I have split and do here. Is it okay to understand that? So now the triangle ABC. Where is B? B is 90 degrees. So here A, here C. Is it okay, children? So ADB and ABC. B angle 90, D angle 90. Like this split means you can understand which are the corresponding sides. Okay, which are the corresponding sides. So which corresponding sides I have to take here? AB square should come, children. AB twice you want. So which side I have to take here? Be careful. So you can take AD by AB, AD by AB, AB by AC. Like this if you take AB twice comes, children. So you can write here the ratio. So if you can't understand, you can do like this. AD by AB. Okay. So AD by AB is equal to, yes children, AD by AB is equal to AB by AC. AB of this triangle, AC of this triangle. Is it okay? So you can write here AB by AC. Like this. See, first AD by AB. Then AB by AC. So AB twice comes means you can get the square of that. Is it okay, children? So like this proportion is equal to 10. So see here, AB into AB, AB square is equal to AD into AC. AD into dot means AC. Okay, dot means multiplication. So AD into AC. So we can write as equation number 1, children. Is it okay? Thereafterwards, another triangle is there. Which is that triangle similar means we know already. Triangle BDC and triangle ABC. In triangle, so they are similar. They are all similar. So triangle BDC is similar to triangle ABC. This I already know through the theorem, previous theorem. Yes, children. So then what are their corresponding sides? Let us write its corresponding sides. Okay, children. So corresponding sides, if you can't understand, you write the triangle separately. BDC. Triangle BDC. BDC. D angle 90 degree only you have to take. Okay. So then ABC. B angle only 90 degree. ABC. Okay. Like this. BDC, BDC, ABC. Now compare which are the corresponding sides of that. We can take now BC square want children. So BC twice I want, twice. Okay, let us see how comes. DC by BC is equal to BC by AC. Hypotenuse here. This one of the sides of the triangle. Is it okay, children? So now see what you can write here. DC by BC is equal to BC by AC. BC by AC. Now just cross it. BC how many times? BC into BC. BC square is equal to DC into AC. Implies what we can write here. BC into BC. BC square is equal to DC into AC. This is equation number 2. Equation number 2. Is it okay? So then one equation and two equations. See, just see this. AB square, BC square. I want this AB square plus BC square. Is what you have to do. These both the equations I have to add children. Can we add this? Okay. So see here what you can do. Add 1 and 2. Add 1 and 2. Add now AB square plus BC square is equal to AD into AC plus DC into AC. Is it okay? So we can write like this there. So see here AD into AC plus DC into AC. Okay. So equation number 1 plus 2. AB square plus BC square is equal to AD into AC plus DC into AC. Both you have to add. So while adding, what will happen here? Who is common in both? This is into children. Okay, who is common in both? AC common. Can I take it out? AC went outside. AC went outside. Means inside who is remaining? AD. Right, AD plus AC went outside. DC. Okay, so now what can I do? AB square plus BC square write as it is equal to AC write as it is. Okay, just see in the figure, see AD plus BC. AD plus BC together is AC. AD plus DC together is AC. AD plus BC sum is AC. So can I take it as AC here? Okay, so remaining is AB square plus BC square. Okay, is equal to AC into AC. AC square. AC square is equal to AB square plus BC square. So that only I want to prove, children. See, AC square is equal to AB square plus BC square. So finally we can write, therefore AC square is equal to AB square plus BC square. Okay, hypotenuse square is equal to sum of the squares of other two sides. This is called the Pythagoras theorem. Very important here. Where there is right angle triangle, you can apply Pythagoras theorem. So that is the use of Pythagoras theorem. Is it okay, children? So everywhere where there is a right angle triangle, it's easily you can use a Pythagoras theorem. Okay, so this is about Pythagoras theorem. The next class, let us move to its exercise problems. Okay, children, till then, take care. Thank you.